Hello everyone. In this video, I will be talking about circles from TSE EAMCET September 10, 2020 Shift 1. So I have already done the questions on straight lines and locus. Now I will be starting with problems from circles. So this is the first problem. 2 points from the set of concyclic points of the circle passing through 1, 1, 2, 1, 2, minus 1 and 3, 2 is what? So there is no other way to solve this problem other than finding the equation of the circle. So let us assume the equation of the circle as x square plus y square plus 2gx plus 2fy plus c is equals to 0. So the 3 points are 1 comma 1, 2 comma minus 1, 3 comma 2. I will be putting these values 1 comma 1, 2 comma minus 1, 3 comma 2 as in place of x and y. I will get three equations. I have three variables g, f and c. I will solve for the variables and then I will be able to solve the problem. So let us first consider 1 comma 1. So 1 square plus 1 square plus 2g into 1 plus 2f into 1 plus c is equals to 0, or 2g plus 2f plus c is equals to minus 2. Now let us consider 2 comma minus 1. So 2 square plus minus 1 square plus 2g into 2 plus 2f into minus 1 plus c is equals to 0. So 4g minus 2f plus c. 2 square is 4, minus 1 square is 1, so 4 plus 1 is 5, so here minus 5. Now let us consider 3, 2. So 3 square plus 2 square plus 2g into 3 plus 2f into 2 plus c is equals to 0, or 6g plus 4f plus c. 3 square is 9, 2 square is 4, 9 plus 4 is 13, so minus 13 here. So the three equations that we have are 2g plus 2f plus c is equals to minus 2, 4g minus 2f plus c is equals to minus 5, 6g plus 4f plus c is equals to minus 13. First I will do 2 minus 1. Okay, 4g minus 2g is 2g, minus 2f is minus 4f, c minus c is 0, minus 5 minus of minus 2 is minus 5 plus 2 is minus 3. So this is equation 4. Now I will do 3 minus 2. So 6g minus 4g is 2g. 4f minus of minus 2f is 6f. c minus c 0. Minus 13 plus 5, so minus 8. Now I will do 5 minus 4. 2g minus 2g is 0. 6f plus 4f is 10f. Minus 8 plus 3 is minus 5. So f is what? Minus half. F is minus half, so g is what? 2g minus 4 into minus half is minus 3. So 2g plus 2 is minus 3. So 2g is minus 5, or g is minus 5 by 2. So what is c? I have value of g, I have value of f. Now I need to find c. So let us use this equation. 2g is minus 5, 2f is minus 1, plus c is equals to minus 2. c minus 6 is minus 2. So 6c is equals to 6 minus 2 is equals to 4. So what is the equation of my circle? I have g, I have f, I have c. So x square plus y square. 2g is minus 5. 2f is minus 1 plus c is what? 4 is equals to 0. Now all we need to do is put these x and y, these points, this as x, this as y, in these two equations. The set whichever satisfies this equation is the correct option. Okay, so let us put option A. So 5 by 2 plus root 5 by 2, this is whole square root of 5 by 2, by the way. 1 plus whole root of 5 by 2. So I will also write this as this. Five by 2 square plus 1 by 2 square is 25 by 4 plus 1 by 4 is 26 by 4 minus 4. 4 is 16 by 4. So 26 minus 16 by 4 is 10 by 4. 10 by 4 is 5 by 2. I have written this so that because there are square roots over here, it will be easier for me to solve. So in option 1, 5 by 2 plus root 5 by 2. 5 by 2 and 5 by 2 will cancel. I will be left with root 5 by 2 whole square. 1 by 2 and 1 by 2 will be cancelled. So I will be left with root 5 by 2. Root 5 by 2 whole square is 5 by 2. This is also 5 by 2. So this is equals to 10 by 2. This is equals to 5. But on my RHS I have 5 by 2. So this is not the correct option. Now let us look at option B. 5 by 2 plus root 5 by 2. Again, I have seen that it will be left with, we will be left with 5 by 2 plus half. So half and half will be cancelled. So there is nothing here. So this point satisfies. Now let us look at this point. 5 by 2 plus root 5 by 2 minus 5 by 2 whole square plus 1 by 2 plus root 5 by 2 minus half whole square. Half and half cancel, 5 by 2 cancel. So root 5 square is what? 5. 2 square is what? 4. Again, root 5 square is 5. 2 square is 4, which is equal to 10 by 4 or 5 by 2. So this option is satisfying. Okay. So that was an easy question, just time consuming. Let us look at next problem. Question 9. If the polar of a point P with respect to a circle of radius r which touches the coordinate axis and lies in the first quadrant is this, then the point P is what? Okay. First I want to draw the circle. This is my axis x, y, origin. I have been given that the circle lies in the first quadrant, so over here somewhere, but it touches the coordinate axis. It has to touch x and it has to touch y axis, right? It's the center. Now the radius is r, so this distance is r and this distance is r. Hence, what is the center? R comma r. So if r comma r is the center and r is the radius, what is the equation of my circle? X minus r whole square plus y minus r whole square is equals to r square, or x square plus r square minus 2rx plus y square plus r square minus 2ry is equals to r square. 1r square is cancelled. X square plus y square minus 2rx minus 2ry plus r square is equals to 0 is the equation of my circle. Now I have a point P. I don't know where the point P is, maybe somewhere here. Let us say x1, y1. The polar of the point P with respect to the circle is given as x plus 2y is equals to 4r. So if the point P is x1, y1, then what is the polar of point P with respect to the circle? We know that for a circle x square plus y square plus 2gx plus 2fy plus c is equals to 0, polar with respect to a point P x1, y1 is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. Hence, similarly, the polar of this point with respect to this circle should be x1 plus y1. What is g over here? Minus r. X plus x1. What is f? Again minus r. Y plus y1 plus r square is equals to 0. Now we have to combine the x terms. So x into x1 minus r plus y into y1 minus r. Now the constant terms. What is constant term here? Minus rx1 minus ry1 plus r square is equal to 0. X plus 2y is equals to 4r. These two equations are equivalent to each other. So let us compare the terms. X1 minus r is equals to 1. Better would be ratios. So x1 minus r by 1 is equals to 1, so it's almost the same. So y1 minus r by 2, so x1 minus r by 1 is equals to y1 minus r by 2 is equals to so this is on the left hand side and this is on the right hand side, so I will have to take it here, rx1 plus ry1 minus r square by 4r. So these three ratios are equal to each other, right? Because these two equations are one and the same, hence I will have to take the ratios of the coefficients of x and y and constant, and all these three ratios have to be equal to each other. So r will be cancelled. So what is x1 is equals to r plus x1 plus y1 minus r by 4, and y1 minus r by 2 is equals to x1 plus y1 minus r by 4. So this will be cancelled. 4x1 is equals to 4r plus x1 plus y1 minus r, and 2y1 minus 2r is equals to x1 plus y1 minus r. So 3x1 minus y1 is equals to 3r, and y1 minus x1 is equals to 2r minus r is r, right? y1 is equals to x1 plus r. I will use this and put this over here. So 3x1 minus x1 minus r is equals to 3r. 2x1 is equals to 4r. x1 is equals to 2r. If x1 is 2r, then y1 is what? r. 2r plus r is equals to 3r. So 2r comma 3r, which is the option, this one. So this was a straightforward problem as well. Now let us move on to the next problem. Question 10. So I think this one is a bit tricky, and you need to be careful while solving this problem. So if the circles this and this, k belongs to z, z means integer, have exactly two common tangents, then the possible values of k is. So first I want to discuss about the number of common tangents for two circles, because that is necessary in order to solve these problems. So I have these two circles. In this case, this can be a common tangent, this can be a common tangent, this can be a common tangent, and this can be a common tangent. So 4 common tangents. If this is the case, so this can be a common tangent, this can be a common tangent, and this. So 4 in this case, 3 in this case. If I have this one, please excuse my drawing. So 2 common tangents. If this is the case, 1 common tangent, and if this is the case, 0 common tangents, right? So we are given exactly 2 common tangents. So this is the case that the circles have to be intersecting. So if my circles are intersecting, so the distance between the two centers, C1 and C2, has to be smaller than the sum of their radius, right? So C1, C2 should be less than equal to R1 plus R2. This cannot be equal, because if this is equal, then this case will happen and I will have 3 common tangents. Also, this condition that the circles cannot be like touching each other in this way. In this case, the distance between the centers is equal to R1 minus R2 mod. This also cannot happen, otherwise I will have one common tangent. So my C1, C2 has to be greater than the mod of the differences, and the distance between my centers has to be less than R1 plus R2. So I will have to solve for these two inequalities in order to find the value of K. Okay. So let us first write so this is the background for this problem. It's a big background. Um, if the circles have two common tangents, so first let's write the equation of the circle in this form: x minus a whole square plus y minus b whole square is equals to r square. Because in that form I will know the radius and I will know the centers, which are a and b. So it is easy for me to implement these two inequalities. So let us first look at x square plus y square minus 2 into 3 plus root 7 y, sorry, I missed the x one, minus 2x plus 8 plus 6 root 7 is equals to 0. So x minus 1 whole square plus y minus 3 plus root 7 whole square is equals to 1 square plus 3 plus root 7 whole square minus 8 minus 6 root 7. I will like to solve it a bit further. One square is 1 plus 3 square is 9 plus root 7 square is 7 plus 2 into 3 is 6 root 7 minus 8 minus 6 root 7. These two will cancel. 7 and 1 is 8, so this will cancel. So 9 is 3 square. So this is my equation of circle 1: x minus 1 whole square plus y minus 3 plus root 7 whole square is equals to 3 square. Now let us look at circle 2: x square plus y square minus 8x minus 6y plus k square is equals to 0. X square plus y square minus 8x minus 6y plus k square is equals to 0. So x minus 4 whole square plus y minus 3 whole square is equals to 4 square plus 3 square minus k square. So x minus 4 whole square plus y minus 3 whole square is equals to 16 plus 9 is 25 minus k square. So now the time has come to implement the inequalities. C1, C2 is greater than mod of R1 minus R2. What is C1? C1 is 1 comma 3 plus root 7. What is C2? 4 comma 3. What is R1? R1 is 3. What is R2? R2 is root 25 minus k square. So let us first implement C1, C2 is greater than mod R1 minus R2. What is C1? 1 comma 3 plus root 7. So 1 minus 4 whole square plus 3 plus root 7 minus 3 whole square root. So I have used distance formula. It has to be greater than R1 minus R2 mod. What is R1? 3 minus square root of 25 minus k square. Minus 3 square is 9. Root 7 square is 7. 3 minus this. This is 16. Square root of 16 is 3. Oh, sorry, 4. So 4 is greater than mod 3 minus square root of 25 minus k square. Right? So if square root of 25 minus k square is equals to 7, what happens in that case? 4 minus 3 minus 7, 4 is greater than minus 4, 4 is greater than 4, so this does not work. So this has to be less than 7. This has to be less than 7 in order for this to work. And since square root of 25 minus k square cannot be less than 0, it is always, radius is a positive number, so this is minimum value, maybe say 0.001, so 3 minus 0.001, so it's 2.99, so that satisfies. So I'm not going to look at that condition. I will only look at the condition in which this becomes greater than or equal to 7, then this inequality doesn't satisfy. So the first condition that has to be there is square root of 25 minus k square is less than 7, or 25 minus k square is less than 49, or minus k square is less than 24, or k square is greater than minus 24. Now whatever may be the value of k, it is always positive and this number is always negative. So this condition is satisfied for all values of k. So we don't need to look at this any further. We will look at the other condition. C1, C2 is less than R1 plus R2. What is C1, C2? I have already solved. C1, C2 is 4. What is R1? We know 3. What is R2? We know this. 25 minus k square. So 4 minus 3, 1. 1 is less than 25 minus k square, or this. I will square. Since both of these are positive numbers, I can square without reversing the sign. So minus k square is greater than minus 24, or k square is less than 24. Since I have multiplied both sides by minus 1, my sign will change. So k square is less than 24. So k is less than root 24 and k is greater than minus this. We know that square root of 24 is what, somewhat like 4.99. So k 4.9. But it is also given to us that k is an integer. So what are the values that k can take? Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. This total is 9. So k can have 9 values. Option C. Okay. So this was a very, I would say, good question. It needs some sort of thinking, not just calculations. Let us move on to the next problem. Question 11. The circle S is equals to 0 cuts the circle C1 is equals to x square plus y square minus 8x minus 2y plus 16 is equals to 0, and C2 is equals to x square plus y square minus 4x minus 4y minus 1 orthogonally. If the common chord of S is equals to 0 and C1 is equals to 0 is 2x plus 13y minus 15 is equals to 0, then the center of S equal to 0 is. So this is also a tricky problem if you assume the equation of circle as x square plus y square plus 2gx plus 2fy plus c is equals to 0 and start solving for g and f and c. It will take you like 5 minutes, so let us not do that. The common chord of C1 and S is given. So if this is the circle C1 and this is the circle S, and this is the common chord, equation of C1 and S, this common chord are given. So I can assume a equation for S easily. Which is C1 plus lambda into common chord is equals to 0. So C1 is given x square plus y square minus 8x minus 2y plus 16 plus lambda common chord is 2x plus 13y minus 15 is equals to 0. So this will be my equation for S. Now all I have to do to solve this problem is satisfy the conditions that this cuts C1 and C2 orthogonally. That's it, and I will have my equation. I will just simplify this. So this is my circle S. This cuts C2 orthogonally. What is C2? We know that if two circles are given by this, If these are orthogonal, then 2g1 g2 plus 2f1 f2 is equal to c1 plus c2. It's very easy to prove. If you want, please let me know. I will show it. But right now, let us go forward with the problem. So what is g1? 2 lambda minus 8 by 2 or lambda minus 4. What is f1? 13 lambda minus 2 by 2. What is c1? 16 minus 15 lambda. You don't have to write g1 as this, f1 as this, as c1 as this, and g2 as blah blah blah. You can just straightforward plug in this equation because you don't really have that much time in the exam. So don't do what I'm doing. I'm just showing so that I'm not making any mistake. You guys will not have this comfort of time which I have. So g1 is given, f1 is given, c1 is given. This is g2, sorry, g2 and f2 and c2. Just plug in this equation and this problem is solved. So lambda minus 4 into minus 2 g1 g2 into 2 plus 2 into f1. 13 lambda minus 2 by 2. What is f2? Minus 2 is c1 plus c2. c1 is this and c2 is this. So minus 2 into this is minus 4, minus 4 lambda plus 16, this is cancelled. 13 times minus 2 is minus 26 lambda, minus 2 times minus 2 is plus 4 is 16 minus 1 is 15, minus 15 lambda. Okay, 15 will come here, so 15 lambda minus 4 minus 26 is minus 30 lambda. 16 plus 4 is 20, 15 minus 20. Minus 15 lambda is minus 5, so lambda is 1 by 3. What is the center of this circle s equals to 0? Minus of lambda minus 4 comma minus of 13 lambda minus 2 by 2. Lambda is what? 1 by 3. So minus of 1 by 3 minus 4 comma 13 by 3 minus 2 by 2. 4, 1 by 3 minus 4, 1 minus 12, minus 11 by 3. Minus of minus 11 by 3 is 11 by 3. 13 minus 6 by 3, 7 by 3. 7 by 3 by 2 is 7 by 6. Minus is minus 7 by 6. 11 by 3 minus 7 by 6. So it was a good problem. Let us move on to question number 12. The equation of the circle passing through the points of intersection of the two orthogonal circles S1, S2 and passing through the point this is this. So let us assume this is my S1. This is my S2. First of all, it is given that S1 and S2 are orthogonal. So it's like this. Right angle, this is R1, this is R2, this is C1, C2. This right angle, so Pythagoras theorem R1 square plus R2 square is equals to C1 C2 square. Okay, and it is given that these 2 points of intersection, another circle S is passing. So let us assume this is my circle like this. S. It can be anything like this as well. Let us assume this is circle S, this one, the outer one. This is given that this passes through minus 1 comma minus 1. So what is the equation of S? Very easy. First we are given that S1 and S2 are orthogonal. What will I use this information for? I will use it to calculate the value of K. X square plus y square plus kx minus 4y minus 1 is equal to 0. 3x square plus 3y square minus 14x plus 23y minus 15 is equal to 0. First I will have to convert this into standard form. So x square plus y square minus 14 by 3x plus 23 by 3y minus 15 by 3 is minus 5. So this is equation 1 for circle 1. This is circle 2. These two circles are orthogonal as I have seen when the two circles are orthogonal. So 2g1 g2 plus 2f1 f2 is equals to c1 plus c2. So 2 into g1, what is g1 for this? K by 2. What is g2? Half of this is minus 7 by 3 plus 2 f1. F1 is what? Minus 4 by 2 is minus 2. F2 is half of this, so 23 by 6. What is C1? Minus 5. What is C2? Minus 15. No, minus 5. Right? I've done everything correctly. Yeah, so let us move forward. This will be 3. This is getting cancelled. So minus 7k by 3 minus 46 by 3 is minus 6. So I will do this. Now 7k plus 46 is 3 into 6 is 18. So 7k is what? 18 minus 46. 7k is minus 28. Yeah. So k is what? Minus 4. So I have solved the equation for circle 1 as I have the value of k. X square plus y square plus kx becomes minus 4x minus 4y minus 1 is equals to 0. Equation 1 and equation 2 was already given to us. X square plus y square minus 14 by 3x plus 23 by 3y minus 5 is equal to 0. Now we have a circle which passes through the points of intersection of these two circles. So that is nothing but this plus lambda into this. Or x square into lambda plus 1 plus y square into lambda plus 1 minus 14 by 3 lambda plus 4x plus 23 by 3 lambda minus 4y minus 5 lambda minus 1 is equals to 0. This passes through minus 1 comma minus 1. Let us put minus 1 comma minus 1 in the above equation. We will find the value of lambda. Minus 1 over here. So minus 1 square is 1. 1 into lambda plus 1. Minus 1 square is 1. So 1 into lambda plus 1. 14 by 3 minus 1. So 4 minus 14 by 3. No, sorry, 4 plus 14 by 3 lambda. X is minus 1. Sorry about that. Plus 23 by 3 lambda minus 4 into y is minus 1. Minus 5 lambda minus 1 is equal to 0. Such a big problem. 2 lambda plus 2, some of these minus 3 is the LCM, so 12 plus 14 lambda by 3, minus and minus is plus, so plus here, and this is minus here. I will take minus inside. 4 minus 23 by 3 lambda, 3 is the LCM, 4 times 3 is 12, minus 23 lambda, minus 5 lambda minus 1 is equal to 0. So 2 lambda minus 3 lambda is what? Minus 3 lambda. 2 minus 1 is what? Plus 1. Okay. Times 3, because I want to get rid of these 3. So what do I get? 12 plus 14 lambda plus 12 minus 23 lambda is equal to 0. So minus 9 lambda plus 3. 12 and 12 is what? 24 minus 9 lambda is equal to 0. So 18 lambda is equals to 27, or lambda is 3 by 2. What is the equation of circle? Put lambda is equals to 3 by 2 in this big equation given here, and you will get the equation of circle. So 3 by 2 into 3 by 2 plus 1 into x square, 5 by 2 x square 5 by 2 y square, right? Minus 4 plus 14 by 3 into 3 by 2 x plus y into 23 by 3 into 3 by 2 minus 4 minus 5 into 3 by 2 minus 1 equal to 0. Lot of work. 5 by 2 x square plus 5 by 2 y square minus 3 and 3 cancels, 7 minus 7 and 4 is 11x, 3 cancelled, 23 by 2 minus 4 minus 15 by 2 minus 1, 17 by 2 is equal to 0. I think there is only one with 5. Yeah, this one. So we will multiply this with 2, 5x square plus 5y square. 11 times 2 is 22. 23 minus 8 is 15. So 30y minus 17 is equal to 0. So this option, this is 15 here and I have 30 for some reason. So 15 by 2 times 2. So sorry, so this is a 30 by 2. So 15y. So 5x square plus 5y square minus 22x plus 15y minus 17 is equals to 0. Option C. Next problem is parabola, and I will be covering this in the next video. Thank you everyone.